A ball is thrown straight upward, or downward, I'm sorry, my mistake, downward from the top of. So the top of a building that's 496 foot, 496 feet high, the building. With initial velocity negative 17 feet per second. This is the initial height. You're on top of that building. What the purpose of these two is to find these two values. Because if you think about it, you go, what is the height at t equals 0 when you were standing on top of that building? You threw the ball down. Well, t is 0. According to this, it's 496, which is equal to what? Negative 16 times 0 squared, plus the initial velocity, which we don't know, t is 0, plus s of 0. And it tells you s of 0 equals 496. That's what the initial height is. And v0 is what your initial velocity. So this equation becomes s of t. I can derive that. That's the initial velocity in a minute. Negative 16t squared minus 17t plus 496. That's the equation that describes that particular story. Somebody on top of a building. The building has a height of 496 feet high. You see your calculus teacher coming out of the building. You just had a test. You didn't do well on it. So you take this rock and you throw it down with initial velocity, trying to kill him, of negative 17 feet per second. You're going to miss him. He's going to run out of the building quickly, you know, knowing he might be on top of the building. So, but that's the equation that will tell you how high that rock at any given time, you know. You tell me what t is, and I'll plug it in. That will tell me what the height. So the 496 will be the initial height, and the 17 is the initial velocity. That's why they call them v0. O in physics means initial. So this is the initial height. Distance, displacement, s is the height. So the question now, what is the velocity? Well, here's the good news. Velocity is actually the derivative the velocity is the derivative of the height or the distance. So if you take the derivative of that, you end up with what? Negative 32 t minus what? The 17. So the velocity at any given time, you tell me when, I'll tell you what the velocity. And negative, by the way, means it's coming down, positive is going up. That's what we use for physics. When the velocity is negative, that means the ball is coming down or the rock is coming down. Because if you remember, this is the positive x direction, that's the positive y direction. So if it's going up, it's positive velocity. If it's coming down, that's a negative velocity. So what is the velocity after 4 seconds? That's negative 32 times 4 minus the 17. So negative 32 times the 4 minus the 17, it is negative 145 feet per second. So that rock is coming fast after 4 seconds. So that's part A. What's the velocity after 4 seconds? The next question, let me write it down here. What is the velocity after falling 195 feet? What's the velocity after falling 195 feet? This is the building. The thing dropped 195 feet. This distance, all of that is 495, right? 496. So when the ball dropped 100, or the rock dropped 195 feet, how high the rock is above the ground? Isn't it the 496 minus the 195? The rock is actually 301 feet above the ground. It fell 195 feet, still 301 feet above the ground. So how long is it going to take the rock to be at that height? Well, go to that equation. We know S of t equals negative 16t squared minus 17t plus 495. Let's set that equal to 301 and find out the time the rock is going to be 301 feet above. Move everything to one side because I like the t to be positive, the squared. What's 301 minus the 495? Is that negative 195? Can we solve for t now? We can figure the time. How long is it going to take the rock? How long it took the rock to fall 195 feet? Quadratic formula, minus b plus or minus the square root b squared minus 4ac divided by 2a minus 17 plus or minus 17 squared minus 4 times 16 times negative 195 over 2 times 16. Negative 17 plus or minus, let's see what that number is. 17 squared, so 4 times 16 times 195. That number becomes a positive plus the 17 squared. The square root of that number, 113 over 32. So we have two answers. Negative 17 minus 113 over 32. Negative 17 plus 113 over 32. Negative 17 minus 113 divided by the 32. Negative 4.06 seconds. Throw that in the trash. Why? Time can't be negative. Negative 17 plus 113 divided by 32, 3 seconds. So after 3 seconds, the rock would have fallen 195 feet. The question is not how long. It says, what is the velocity after falling 190 feet or 195 feet? Well, we know what the time. The equation for the velocity doesn't depend on distance. It depends on the time. This is the velocity. It says, tell me the time, I'll tell you the velocity. Now we know what that time is, 3 seconds. So the velocity at 3 seconds is going to be negative 32 times 3 minus the 17, negative 96 minus 17. Is that 113? I think. So the rock actually is falling. It's falling at a speed of negative 113 feet per second. Negative means it's coming down. So that was a trick. You should remember, if they ask you for the acceleration, which we didn't do, so if you have the distance here, what was it, the distance? Negative 16t squared minus 17t plus, was it 496? The velocity is the derivative. The derivative of the distance, or the height, which is what? Negative 32 t minus 17. They didn't ask you for this, but if they did ask you for the acceleration, guess what the acceleration is? It's the derivative of the velocity. It's the derivative of this. And the derivative of that, which is what? Negative 32 feet per second squared. What is gravity on Earth? Anyone? Meters per second squared. And feet? 32 feet per second squared. So the velocity is the derivative of the distance. The acceleration is the derivative of the velocity, or we call that the second derivative. That's coming up, higher order derivative. You can take the second and the third derivative. The second derivative of this. The first derivative gives you the velocity, and the derivative of the derivative, which is really the second derivative, that's your acceleration. So you'll hear that a lot in physics there. Acceleration, velocity. Velocity is the derivative of the distance. Acceleration is the second derivative of the distance or the height, or the derivative of the velocity. And the last question is number 20. Another physics problem. A projectile is shot upward. That means initial velocity is positive from the surface of the Earth with initial velocity of 82 meters per second. Initial velocity, V0, that's initial velocity, positive 82 feet per second, is shot upward. Do we know what the initial height was? Use the position function below for a free-fall object. What is the velocity? 2 seconds, 10 seconds after. So here's the equation for that. The height is negative 4.9 t squared. Oh, sorry, this is not feet per second, that's meters per second. Because that's acceleration, meters per second squared, plus 82 times t, plus they give you some initial height, which we have no idea what that number. They never told us from where. From Earth, but it didn't say from the top of building 17 here, or from the top of the Sears Tower, or from the top of the Empire State Building in New York. So we have no idea what the initial height. It doesn't really matter, because the question, what is the velocity at 2 seconds? And what's the velocity at 10 seconds? Now, when you shoot an object, doesn't matter where you shoot it from, projectile, it goes like this. So your velocity could be positive, could be negative. If it's going up in this direction, that's positive velocity. If it's coming down on this end, it would be what? Negative velocity. So we'll see what our answers. Well, the velocity as a function of time is the derivative of this. And what's the derivative of that? That'll be negative. What's 4.9 times 2? 9.8t plus the 82, the initial velocity. So what is the velocity after 2 seconds?
How do you know that the velocity is a derivative of the original equation?
That's velocity is always the derivative of the distance, and the acceleration derivative of the velocity. Yep. Just got to memorize that. The velocity is the derivative, because the definition of velocity is change in distance over change in time. Distance over time. And that's why if you take the limit there, that becomes the derivative. 2 times 9.8, that's a negative value, minus the 82, or plus the 82. This will be what? 62.4 meters per second. So it was actually on the way up. The velocity was somewhere here, and that's the velocity going up there. That's why it's positive. Now it's going to come down on the other end. What's the velocity after 10 seconds? And that's negative 98 plus the 82, not 30. Is it 82? Yep, 82. Plus the 82, is that negative 14, is it? It's negative that because it's right here. It reached the peak value, now it's coming down. So that's why the velocity is negative after 10 seconds. The velocity is positive, it's going up, it's coming down. But the velocity is always the derivative of the distance, Nico, and the acceleration is always the derivative of the velocity.